So, good morning or good afternoon, everyone, based on whichever hemisphere you are joining from, and a warm welcome to this special session hosted by IATBR in the seventh BTR conference titled Bridging Borders Global Cross Country Insights on Travel Behavior. So today's session aims to explore cross-country differences in key transport indicators, where we aim to identify best practices, policy gaps, and innovative strategies that can inform transportation planning and policy development worldwide. Just a quick introduction about myself. I'm Ishan, a postdoctoral research fellow at the Institute for Transport Studies in University of Leeds, and it's an honor to chair this session. So before we start, some of the ground rules. We'll have 15 minutes for each speakers, followed by question and answer for 3 to 4 minutes. And I encourage all of you to post your questions in the chat or raise your hand at the end of each talk. And if we couldn't get to your questions, for like every questions, and then I'm sure the speakers would be quite happy if to hear from you directly afterwards this session and beyond that. And so without further ado, I'll say that we have fantastic lineups of speakers today across 5 different nations and 3 different continents, much to the true international nature of the BTR conference. And with that, I'll open our first speaker. I open the floor to our first speaker, Dr. Pratik Bansal from National University of Singapore, who is leading research at the intersection of AI and behavioral science. Today, he is going to present a cross-national analysis of electric vehicle discontinuance in the United States, China, and Germany. So the floor is all yours, Dr. Bansal.
Thanks for the introduction, Hassan, and the invitation by IATBR. So I'll just directly jump into the presentation as I have only 15 minutes. Yes, great. Let me see. Can you see my presentation slides?
Yes, perfect.
Perfect. So I'll be mainly talking about the discontinuance behavior in electric vehicles. There is a lot of literature on what factors affect the preferences for electric vehicle, but still there is a very little literature on what are the factors that might affect the discontinuance of electric vehicle. Obviously, this study is not causal, or this study doesn't say much about, oh, this is the reason, still associational, but we will get some insights at least that what may be different in those who are continuing battery electric vehicle and those who are not continuing battery electric vehicle. And this is a joint work with Eugene Kim, who is an assistant professor at Ajo University, and Rubal Dua, who is a research scientist at the CAPSEL. So just to give you a brief idea about how quickly we are increasing our fleet of electric vehicles, as you see from the graph, the growth is quite exponential in terms of if you look at the sales in 2024, 20% of the vehicle sales were electric. And most importantly, the battery electric vehicle sales are increasing with increase in driving range and the infrastructure globally. And by the end of 24, around 4% of the global passenger car fleet had electric cars, right? So it's quite encouraging in that sense that the trend is quite positive. But what we have been observing in last few years, that there is just some reverse trend where those who own electric vehicle, they're shifting back to internal combustion engine vehicles, ICEVs, right? So there are some studies, some very recent descriptive studies where we learned that, okay, 51% of the used Teslas are traded with ICVs in 2024. Similarly, the McKinsey did a very large global study, and 29% of EV owners are considering switching back to ICVs. And one of the studies by Hardman and Thal, which was published in Nature Energy in 21, I think that is the study which started this discussion about discontinuance, and we have to think about this issue as well. So they had a panel data, and from that, they could estimate that 18% of the VEV owners didn't repurchase EVs in California. So there is some evidence that, okay, things are going in a different direction as well, and we have to investigate this different direction. In terms of the gaps, there are only a handful of studies. I didn't do the full review in the presentation, but maybe 4 or 5 studies in total out there who are thinking about the repurchasing decisions of the battery electric vehicles. And most of the studies that we have are in the US, not in the other areas. And the major reason behind this is the data. Because how do you get the data on VEV owners who had VEVs earlier and then discontinued later? It's very difficult to do. And we're not saying we have sorted out this issue fully, but we tried our best in this study. And you will see there are still many loopholes, but this is just a step forward in this direction. So we are presenting the first cross-national analysis, and we do a survey in the US, China, and Germany. And that survey is mainly for current BEV owners and the former BEV owners, and I'll talk about that in a minute. So there are two main objectives of the study. First, we try to quantify some indicator of the discontinuance rate. That, okay, how much is actually the discontinuance rate of the battery electric vehicle? Can we quantify from the survey, even if it's not perfect, but we might get some idea. And the second is, what are the factors which might tell us association between who are more likely to discontinue compared to those who are not? So we can see how these factors are different across countries. And as I said, this is not a causal study. We will be looking at the associations. And as I said, this is difficult to collect data. So it's more of a step forward with many more directions for future work. So let's look at the recruitment part. So we did a web-based survey using the Qualtrics panel and targeted primary VEV owners in the US, China, and Germany. And we made sure that the survey is translated in Chinese, English, and German accordingly. And we just for simplicity or making sure that sample is more targeted, we included respondents who primarily owned or leased VEVs and screened out the secondary VEV users. Right? And we categorize participants as a current and former VEV owners, and former VEV owners are those who previously owned or leased and primarily used BEVs, but they no longer have any BEVs in their households. Okay, so the household is important, that they have completely discontinued BEVs from the household. Okay. And what you see in the table is basically the composition of the sample. So we have around, in each country, 500 to 600 valid responses. And as I would like to emphasize, these are current VEV owners or those who had VEVs in the past, but now discontinued. So in the current VEV owners, we have a relatively larger sample, and as expected, former VEV owners, and there are not many as well, right? That they have discontinued VEVs and now switched back to something else. Great. So this is just a composition of the sample. So let's first try to understand how can we quantify the discontinuance rate from this. And that's not perfect, as I said, but let's try to go forward in that direction. So VEV discontinuance group is quite clear. These are former VEV owners are the VEV discontinuance group. But we have to figure out the VEV continuance group to be able to identify whether we can say something about the discontinuance rate, perhaps. So what we do is we try to segment the current VEV owners based on vehicles they previously owned, the fuel type of that. So here what you see in the pie chart is the different fuel types of the former vehicles of the current VEV owners. And if you look at here, what you see in this color here in the blue, you have those current VEV owners who also had earlier VEVs in the past. So these we put them in the continuance group, but if someone had ICEV in the past, but now switching to VEV, we don't put that person in the continuance group because that's basically a first-time VEV buyer. We can't call it a VEV continuance group, right? So, and former VEV owners, all that constitute to the VEV discontinuance group. Now we know there is no representative sample, or we don't have any weights really to directly use it. All we are assuming is Qualtrics is kind of doing a random sampling, and they are randomly inviting the respondents because there was not any quota that we set. So the underlying assumption, which is obviously not always true and might not be true in this case, but for the time being, if we assume that the Qualtrics sample is representative, then VV ownership in the US sample, we have, let's say, n equal to 552. We have current VV owners, which are 481. And among those who repurchase VVs are 192, just to indicate I'm talking about this area, who already had VV in the past and also now purchase VV. So we have some idea of the who repurchased VVs. And the former VV owners that we collected is 71 in this case. And that's how we kind of use these two numbers to kind of get the indication of the discontinuance rate in each country. For the US, we had one more study in the past on the discontinuance, which was on the revealed preference data, not on the stated preference data, and which was new vehicle buyers data, which was a large data set. And from there, the discontinuance rate that we obtained was 35%, but it included the plug-in EV, not just battery electric vehicle. So from that sense, we feel this number is not entirely off the charts, but it gives a reasonable estimate of how the discontinuance rate changes across countries. And here we see it varies a lot across countries. It's 27% for US, 38% for China, and 50% for Germany. Now, second part is what is different between this continuance group and the discontinuance group. Sample is not that large, so we don't do any fancy analysis, but we just apply a logistic regression to understand that what is the probability of this demographic group or this specific characteristic to be in a continuance group or the discontinuance group. But before doing that, we have one more information about the satisfaction of people on the different attributes. So we wanted to include the satisfaction. We wanted to control for the satisfaction when we were doing this logistic regression. So rather than having so we have satisfaction on many variables related to the charging time and driving performance, driving range. So we didn't want to have all these variables in the model. So we tried to just apply the latent class cluster analysis and found the probability of that person belonging to the either satisfied owners or the dissatisfied owners by classifying them into the two clusters. And we were able to easily identify that these are dissatisfied and satisfied clusters based on the probability distribution of the responses for each variable within each class. So let's quickly go to the some main results of the logistic regression, which just tells that what is the probability or the likelihood of that group into the discontinuous group. So I'll start from the bottom of the table, which is the latent class which we created. That if someone who is satisfied, then the probability of discontinuing being in the VB discontinuance group reduces. But that's true in United States and China. In terms of public charger, home charger, and workplace charger, the pattern is quite interesting. If you specifically look at the public charger mainly the accessibility to public charger reduces the likelihood of discontinuance only in Germany, at least what we can see from the results here in terms of the associations. And if you look at the home chargers, they reduce the likelihood of the discontinuance in both China and Germany. But what comes significant in the US is mainly the workplace chargers, which also help in Germany context, right? In terms of the household ownership, who are single vehicle household, they're less likely to discontinue. And in terms of the education, we see that highly educated people are less likely to discontinue in United States and Germany, but this effect is not so significant in China. So all we can see here, the factors that are associated with the the likelihood of being discontinue and continue are quite different across countries. When we look at the barriers, so we had one more information about the top 3 barriers that people in the discontinuance group report, which are the former VEB owners. And from that, what we are presenting here is the frequency distribution of the top 3 barriers preventing VEB repurchase. And the different bars represent the different, for different countries. If you look at US, certainly public charging accessibility on highways and the long recharging time turns out to be the key factors. But we have this only for the VEB discontinuance group. And as I said, we have some information about the satisfaction and the dissatisfaction on these attributes as well from the both groups. So we present that information and do some chi-square test to see if this is specific to the discontinuance group or the people in the continuance group are also dissatisfied with this. So when we look at the chi-square test, we find that from a satisfaction wise, there is no specific difference based on between these two groups in the long recharging time and the public charging accessibility on highways. So these seem to be the shared concerns in the both who are continuing and the discontinuing in the US. In China, if we look at it, then driving range turns out to be disproportionately more important compared to other barriers. In German respondents, what comes interesting here is the driving performance, which is here, becomes more important compared to all other factors, which was quite interesting when we look at the barriers to the VEB repurchase behavior. So in summary, I would like to emphasize that the discontinuance rates are different across countries. As I said, these numbers are not perfect, but indicative to an extent. Social-demographic influence are also different across market. For example, education reduces discontinuance is associated, I should not say reduces, but is associated with the discontinuance in the US and Germany. Similarly, if you look at the home and public charging, access also influences the VEB retention differently across markets, as we have seen that German cares a lot more about the public charging compared to the others, maybe because of the lack of home charging availabilities, the way housing structure is defined. And when we look at the key barriers that also vary across countries, for example, on the driving performance, but US focuses on the highway charging and the charger time. Thank you. That's my presentation and happy to answer any questions you have.
Thank you, Dr. Bansal. That's an excellent presentation. So with that, I'll open the floor for questions.
I can already see one question by Rishi. Yeah. And then Karishma. So I'll first
Also,
answer Rishi's
feel
question.
free to raise
So
your hand and unmute yourself and ask questions. So that's also completely fine. Yeah. Yes, please, Dr. Bansal.
So for the barriers, we ask them the top 3 barriers, and for each respondent, and the proportions that you see are exactly showing that what proportion of the respondents are putting those barriers in those top 3, their top 3 barriers, right? So that's what the barriers questions, that's how the barrier question was asked. And the number of vehicles owned was the number of vehicles owned at that moment, right? And at the time, that's what I remember, but I need to cross-check on the number of vehicles, how that variable is defined. But mostly for the number of vehicles at the time of the survey, that's what we. Karishma has a question about. Yes, we do have information for the discontinuance group. We do have information on that. It's all, but I haven't presented here. We do have information on that those discontinuance group where they switched to. Yeah. I can provide you summary statistics later, Karishma.
Um, so I'll just have a quick question. I find it really interesting that there are some little difference between the barriers they actually reported, the
Mm.
top three barriers, and the barriers you found when you analyze them statistically through the logistical model. So
Mhm.
what are the reasons for that? For example, in Germany, they have some problem with the accessibility, but when they reported, it was some different uh,
So,
metric.
so that's a very good question. I think the major difference here is the logistic regression tells what is different between two groups. But what we are reporting here is only by the discontinuance group. So it's possible that the whatever is the barriers reported by the discontinuance group might also be there in the continuance group. So in that case, your logistic regression will not give the statistically significant results. So that's one of the reasons that these two analyses is a bit different. And that's why we connect it with the satisfaction level across attributes rather than the logistic regression results, because it's difficult to connect with the logistic regression.
Great. Thank you again. And with that, we move on to our next speaker, which is Professor Amit Agarwal from Indian Institute of Technology, Roorkee, specializing in transport emission modeling and sustainable mobility. And today he's going to discuss how information dissemination affects traveler choices based on real-world evidences. So, Professor Agarwal, the floor is yours. Feel free to
Hey,
share
hey,
this.
good morning. Good morning, Ishan. Good morning and good afternoon, everyone. I hope I'm audible.
Yes, perfectly. Yeah.
Okay. Can you see my screen? Ishan, can you please confirm if you can see my screen?
Yes, I can see it. Maybe you can just put it on the presentation mode.
Is it better?
Uh, yes, it's perfect now. Yes.
Yeah, so thanks, Ishan, for the kind invitation. So here today, I would like to just show work done by two of PhD scholars at IIT Roorkee. They have two different dimensions, but the common point there was how do we use the information dissemination approaches and nudge the travelers to different choices, possibly with respect to their health or more towards sustainable modes. So to start with, just like a really the information dissemination is just not really new. It's just like ancient phase was the more of public announcements. Moving fast forward, it was more like a bit of newspapers. Even in some parts, this is newspapers. Then we had videos, televisions. Depends on the kind of information which is being shared. Then we have coming more close to the ongoing century. It's more like we started having these digital displays where we started showing the different type of information, whether it's with respect to the weather, a foggy situation, or maybe some sort of a bottleneck or incident, etc. Many of those things are still ongoing, but some of those things are now moved to the more real-time information on the smartphone. So what we see here is initially the ancient way was more one-to-many. We are reaching to one-to-one information dissemination approach there. We can even try to personalize the information what is being shared with an individual user. So just the to give the brief now, coming directly to travel, like what typically a person would need is about their mode of travel, which route I may take, what time I should depart. With respect to those mode characteristics, how much time would it take, what would it cost, what would be the schedule so that I can take a particular bus or metro. A few people also try to look comfort and safety and then other qualitative measures to take the final call on their decisions, choices. But then some other aspects which we have also focused in this particular work was crowding in public transport and air pollution exposure. Now, these two things are becoming prominent issues. Like air pollution is well-known issues in many Asian parts, including India. So this is what we have tried to put together, like how we can use the information dissemination and then see the choices of the traveler. One thing which I would like to highlight here is the information sharing way. Like there's plenty of resources available for pre-trip planning, where we can basically get all possible details between an origin destination, whether we like to have information of the route, travel time, travel cost, toll, parking availability, and then even for transit schedules. On some information is available in aggregated fashion. Let's say typically what is the typical AQI in a region or even for a city. So this is where our target was for air pollution, and so that was the gap which we considered. And from transit schedule side, it's more of the only the schedule or time information which is available. So how this information would be useful? People can make a call for their different type of modes. They can try to take a call on their routes, or they can even try to change their departure times. There are studies which also demonstrate that people may be willing to take the next bus depending on the availability of the seats in the bus. So now, to briefly summarize what we have actually covered in these two dimensions is basically if a person is just traveling between an OD pair and then it would like to see how many seats are available, or not just the seats, it's also like if enough standing spaces is available, because this may have a discomfort and then people may switch to other routes. On the other hand, between an origin destination, we wanted to look at it if people do really understand that aggregated information. So for instance, we did a survey in an earlier study where we tried to look at in Delhi that how many people are able to actually understand what is being shown there. That's AQI, is air quality index. Only 27% of respondents were able to understand. But when we try to explain it to them and understand that they are really willing to switch, there are some information, then they have adapt to these different routes given the information is shared in an appropriate way. I will try to describe the follow-up results based on that. Let's say how much trade-off they are ready to consider. So this here is we try to give the information on their crowding and then see how it's valued. And here it's basically we try to give them real-time information on the exposure. It's not exhaust emission what we are trying to look. We are trying to look at how much impact it may have on their health in terms of PM 2.5. So we did face-to-face primary data collection, which had a few like screening questions, trip characteristics, perception statement, and so on. For obvious choices for air pollution, our sites selection was Delhi, which is having a major issue. As I told earlier, like we saw a willingness. We also studied to see if there is a possibility to find alternative routes, meaning is the air pollution exposure more or less same, or is it also heterogeneous depending on the location? I will brief here like how we are getting this air pollution exposure information. So we deployed around 15 devices on different buses in New Delhi, which were measuring temperature, .5. That data for 8 to 9 months. And then we use that data to process, we develop prediction models so that we can check information. We use now destination and then try to get the, let's say, greenest calling in the. So I was just trying to brief here about how we have collected the data to facilitate the real-time air pollution and congestion levels. Now, this portal, what we developed using the real-time data as well as the historical data for predictive planning, we embedded this in our survey tool, and this is here. So we call it as Travel Surveys as a Service. This is an in-house tool where we have integrated actually this whole platform. So while doing the primary data collection, we asked origin, destination, and then based on those information, these routes were proposed at site. Now, this here, for instance, is coming directly from the router, and then we use D-optimal. So we had different levels to understand their willingness to shift with respect to time and cost, and at different levels of air quality. This here is just to illustrate how these are two choices, two alternatives are proposed to the respondents, and then this is actually how it was shown to them. Not this is just for descriptive purposes to explain it. So coming to results first, so we here looked only at the route choice of the motorized and non-motorized mode. So we looked at the different observed items and then tried to derive the two latent variables out of it. One was information seeking proactive behavior, another was how aware they are based on that. So together with the travel attributes and then socio-demographic attributes, we developed a utility model. Now, this here is basically a positive ASC is showing an inherent preference to the faster mode. As the travel time increases, they are ready to shift to the faster mode and similar to the cost. For the awareness, for this latent variable, it's a really small, but important thing is here. And then I will also show you for the non-motorized modes, the results are even more interesting. So here is people who are using the private mode of transport, they are more prone to have higher income. So they already have, it's implicit in their behavior, like people are using cars, so they already have it in mind that even if there is a pollution, use of air conditioning is not impacting on their health much. So this is showing an inclination towards use of this least exposed to air pollution routes. Now, here is for non-motorized mode. So I will, given the time, just talk about the two latent variables, which are more important part here. This here is first like awareness and proactive behavior. So these are the people who are more like from the lower income group. So they are rarely aware of more information about it. So they do not have a willingness to switch. It's the negative is not like they are not unlikely to switch to more lead, but as soon as we give them the detailed information about their exposure to the air pollution and health, we see a strong willingness to switch over there. We looked also at the trade-off. So this coefficient for the exposure versus with respect to the travel time. So we call it as marginal rate of substitution. I will give this detail over here with a comparison of different studies. We had collected the data only in India. So, but for comparison, we tried to look at the studies from different parts of the world. So, for instance, some of the studies which were looking in the non-motorized transport where bicycles is there, and one was on the exhaust emissions, and then these were looking also on the route choices only. Now, there was one study which was trying to see the trade-off, the quantifiable trade-off, which we, but here it was shown as like respondents are willing to take 4-minute longer routes for a drop of 5 ppb for NO2. Here we considered PM 2.5. So to have the same level, we converted all those indices to normal scale using air quality index, which results in, for instance, 4 minutes of a drop of 5 ppb NO2 to 14 minutes of PM 2.5. Now, an interesting observation here is for instance, the trade-off for non-motorized transport is 8 to 30 minutes. That's a lot. if we look at the aggregated numbers. And then for motorized, it's 14 to 48 minutes. These ranges are depending on the different levels, let's say from very unhealthy or hazardous to healthy, and so on. The one reason of those higher ranges is the typical average trip length. And then now, so if we try to normalize that also, so for 1 hour of trip in Toronto and Montreal, people are ready to take about, let's say, 28 minutes, and in Delhi, it's 38 minutes. It's not a direct comparison using the same data, but at least it gives a fair comparison that, okay, if we give the right way, if we disseminate the information in the right way, people would be willing to switch. Now, for public transport, we are still, this is an ongoing work, but we looked at the perception of the people from the crowding perspective. We are yet to get the results that how much trade-off they are willing to take in terms of travel time or the different choices. But what we try to look at here is if they are traveling in a seated versus traveling in a standing position. So how they are perceiving the travel time. Let's say if they are traveling in an uncrowded versus crowded situation. So that's how this logic of time multiplier is this here is just simply the 1 plus beta travel by beta time. So it's this additional load with respect to k is the density, which we are considering here is the standing density. And then this is in the seated. So if you are seated and then there are people standing nearby, and then if you are feeling some discomfort with that and with respect to the standing. So we again provide use this travel surveys as a service, TSAS platform to collect the data. These are the results. So here, if we look at the right side, the chart here for the number of passengers per square meter. So typically aligned with the literature, the densities are taken as from 0 to 6. The blue is the time multiplier in seated, and as expected, it's smaller, like varying between 1 to 1.5. But suddenly for the standing multiplier, what we were able to achieve is much, much higher, which is also expected. But the values are as I will show the international comparison, it would make a larger differences. Now, what is interesting observation here is when we look at the heterogeneity in this different socio-demographics. So just for illustration, I'm showing the gender. I will just take maybe another minute. So the change here is like, for instance, if the let's take this example, 2 passengers per square meter. So compared to male, females are perceiving a much higher time multiplier than male. This is aligned with the for instance, the specific buses or coaches reserved for women, and this is as observed in different parts of the world. So this would encourage more women travelers to use this. Now, what we have not done is the time multiplier would be same for a female passenger if they are traveling in a mixed coach versus a dedicated coach for. My last slide here is just for showing an international comparison of this data. What we collected is, for instance, here. Now, looking at the sitting multiplier, that is the bottom left. The time multiplier is sitting at the bottom of comparing across the other countries and other cities, and whereas for the standing, it's much higher. Now, reason is for instance in indoor. So even if they are seated, they do not feel so discomfort compared to other cities. They are okay if more people are standing around it. But on the other hand, if they are standing, it's giving a lot of discomfort to them. So meaning like seated is still fine. Here we have to kind of consider that as soon as people would start standing, they may be attracted to more different type of modes. Concluding, with these two basic studies, we have tried to show how the real-time information can nudge the users to make different choices, safer, less polluted, and then more healthier. There are different ways of information dissemination which we are yet to take account of, but that would really help. The easiest is more on the smartphone, which can be configured to the individual levels. So thank you so much. I would be happy to take up some questions.
Thank you, Professor Agarwal. It's an excellent presentation. So I'll open the floor for questions, and to everyone joining today, so you feel free to unmute yourself and ask the questions directly. And you can also use the chat box.
Thanks, Amit. I think it was an interesting work. I just wanted to give a comment rather than a question. We tried to see whether male and female have different crowding multipliers in Singapore, and we didn't find any difference. So it's very interesting to see the differences you're getting. So it was a null result, so we haven't reported it as such, but very good to see the differences, the stark differences you have in the Indian setting. Thanks.
Yeah, maybe I will share some findings what we have, Prateek, and maybe try to look at this, because this is also what we initially thought of, like do different geographies have some implicit perception of the crowding in it. Yeah, thanks.
So I have a quick questions while others come in. Have you considered the reveal preference also along with the stated preference? Because if I understood correctly, your data set is the stated preference one.
So for the choices, yeah, it's stated, but the alternatives which we derived are based on their revealed preferences. So
Okay.
that's the portal which we have is they enter their actual origin destination, so during their travel, including the time, and accordingly those stated choices, alternatives are derived.
Okay. Okay. I got that.
Yeah, if there are any questions, would be happy to take up them by email as well. I know I think I may have delayed the session
No, no,
because
no.
of that.
It's not at all a problem. So then with that, we'll move to the next speaker. I guess there are no more questions. Okay, so we'll move to the next speaker, who is Professor Nobuhiro Sanko from Kobe University. He's an expert in transport planning and demand forecasting. And today he will speak about transferability and data for modeling travel behavior. So Professor Sanko, feel free to
Yes.
start.
Yeah, thank you for your introduction. Can you hear me?
Most welcome.
Yeah, so slides is fine. Yeah, okay. So today I will talk about transferability and data for modeling, because for cross-country insights, transferability is an issue. Today's talk is based on my own research on temporal transferability using data from Nagoya, Japan. These are my own research, and some notes on spatial transferability. So the study area is Nagoya, Japan, household travel survey data that is repeated cross-sectional data. The commuting mode choice models were estimated. Logit model with three alternatives, rail, bus, and car. And the explanatory variables, I didn't include travel cost because usually in Japan, commuting passes are paid by companies. First, 10,000 observations were chosen from each year to make a comparison fair. So we have 4 data points, and we assume that we are now here. So we have data from 3 time points for modeling, and data from 2001 is kept for validation. The modal share in the study area is like this. So rail share is relatively stable, but bus share is declining and car share is increasing. The first question is, which data should we use? So if we use only one data, we can use 71, 81, or 91. The results are here. The forecasting performance, this is the actual modal share in 2001. These are predicted share by models estimated by data from 71, 81, and 91. So you can see that 91 data has very close to 2001, figures in parentheses differences between 2001 and 1991. So the message is using the most recent data is better. But next question is, how about using data jointly? Cross-sectional survey data is costly, and so if we use only the most recent data, we have to repeat the same size of survey repeatedly. But we already have data from all the time points, so just ignoring these data is not a good use of data. So an idea is to use these data jointly, but we made an assumption that parameters can change over time. For example, travel time parameter can be a sum of base parameter and historically changing parameter. So in this formulation, parameters are functions of year, so the future parameter values can be forecast. Another idea is a function of GDP per capita. So if the GDP changes, the parameter also changes. The results are here. Again, this is the actual share. This is the best model when we use data independently, only 1 year. This is results of 3 time points jointly and using function of time, that is function of year. And here is 3 time points data and function of GDP per capita. So this suggests that functions of GDP per capita is better. So this message is not clear and just a mistake. So using data jointly is better than using the most recent data. So next question is, when we have data, larger older data or smaller recent data, which data should we use? Large household travel surveys are not conducted frequently, so when we build models, household travel survey data can be old, and we may be interested in collecting new data, but conducting survey by ourselves is very costly, and the number of observations shall be small. So this indication shows that year 2 is larger. That means more recent. The number of observations is larger in older time points. Here, we did a bootstrapping, and Y is year of data collected, 3 time points, and N is the data size. We tried 33 patterns ranging from 50 to 10,000, and B is a Bayes random resampling with replacement, because we try 33 patterns, but just drawing once maybe may not be good, so we repeated 200 times. And in the following studies, I use basically the same idea, but the number of N and B differ in some cases, but this is not a main concern. Here is the results. So this means the average log likelihood on the 2001 data, that is a forecasting performance. the higher value is better forecasting. So this axis shows the number of observations used for modeling. So these three lines are year of data used. This trend rising to the right means that when we use data from the same year, the larger number of observations lead to better forecasting. And when we see this part, for example, when we have the same number of observations used for modeling, the more recent data produces better forecasting. However, there may be a trade-off. For example, here, to achieve this forecasting performance, 1991 data needs 150 observations, but 1981 data need 350 observations. So that is a trade-off. This is a standard deviation of the log likelihood on the 2001 data. This axis is the same. So using the same year data, the larger number of observations leads to more stable forecasting, and the number of observations is the same. More recent data generally produces more reliable forecasting. Here is the summary of this study. This axis shows the number of observations from older time points, and this is the number of observations from more recent time point. This gray hatched part shows not our interest in the study, because this area shows that the number of observations from the more recent time point is larger. So we already know that more recent data is better. The larger number of observations is better. So this part is not our interest. This part is our interest. So this shows that this part means that smaller, more recent data produces statistically significantly better forecasting. So 350 observations from 1981 is statistically better in forecasting performance than 10,000 observations in 1971. When we change the year, so the number of observations differ a bit, but the trend are very similar. Another question is, how about using data jointly? When older data is large and smaller, more recent data is small, we know that model updating techniques. So transfer scaling, joint context estimation, Bayesian updating, combined transfer estimation, these two model updating methods were compared with small sample model from the more recent data set. These four uses both data, but here this uses only the most recent data. The results are here. So updating methods utilizing data from 2 points in time, these never produced statistically significantly better forecast than this model. So this questions the use of conventional model updating methods. But here we analyzed not statistically significant, but in some cases, model updating methods produces better forecasting than the other models. So in some special occasions, transfer scaling, this joint context estimation and transfer scaling can be better. This is further extended to the case that more recent data is larger. Usually, model updating is not used when the more recent data is larger, but we applied this updating function approach to this case also. So results are here. So due to time limitation, I just read here. The updating function model often produces statistically significantly better forecasts than models using only the more recent data. The study extends the applicability of the model updating to cases in which the more recent time point has more observations than the older time points. Then, spatial transferability for vehicle ownership models. So we have data from Bangkok, Kuala Lumpur, Nagoya, and we estimated models, Kuala Lumpur, Nagoya, and applied to Bangkok. So the smaller figure means better forecasting. So for forecasting Bangkok, using Kuala Lumpur is the best. But among Nagoya models, the older Nagoya model was better because similarity in economic conditions. So I skip the Kuala Lumpur, but the message is the same. So spatial and temporal transferability. Here, model in area A at T. So this is transferred to area B. This is spatial transferability. And at T is transferred to T plus 1. This is temporal transferability. However, when models are transferred to another area, that can be used for forecasting in the future. So this transferability also important, but rarely studied. But please find this paper, and we also say that this is important. So nearly close to the end. So there must be a trade-off between smaller and more frequent surveys and larger and less frequent surveys. The work is still in progress or under review, and I think this is better in forecasting. Another data issue is low response rate. For example, in Nagoya case, between 1971 and 2001, response rates was 90% or 75%, but declined sharply to 32.4% in 2011. So here is conclusion. Recent data are generally more variable, but context matters. Conventional updating methods are effective only in limited cases. Updating function models may outperform models using only recent data. Smaller, more frequent surveys deserve consideration. Temporal transferability of spatially transferred models is a topic for future study. Updating function using economic variables may improve spatial transferability. So this relates to this study. Yeah, thank you. And questions and comments are welcome.
Thank you, Professor Sanko. It's really an interesting presentation. And I think this opens up avenues for studies in the global south when we are often faced with the choice between the old large data set or collecting a very small data set in recent times. So this could be a very good addition to that. It can bring new avenues. So with that, I'll open the floor for questions. As I said, feel free to unmute yourself and ask questions directly to Professor Sanko. So since let's wait for others to come in, I had a very quick question that have you tried seeing how the model performs if you use some completely different context, like not those cities, maybe cities from other countries in the world, whether the model will still perform this well or there are other contextual factors that can matter?
Yeah, thank you for your question. So you mean like this? So Nagoya and Kuala Lumpur, for
Mhm.
example. Yeah, so this study showed that the context matters and so Nagoya data, so we have 3 time points, but year uh, that the economic condition is similar to Bangkok, so that was more transferable. So is it answer to your question?
Yeah, I got that. Yeah.
Yeah, so
Thank you, Professor Sanko. I hope people might come up with questions at later stages too, and they might also can directly ask you questions. Thank you once again. And with that, we'll move to our next speaker, Dr. Fangxin Song, who is also my colleague at University of Leeds. And today she will share a research about a cross-country comparison of travel preferences regarding air travelers. So Fangxin, the floor is yours. Feel free to share your screen and start the presentation.
Thanks, Ishan. Let me share my screen. Just give me a second.
Sure.
I hope you're seeing,
Yes.
you can see the
Yeah.
slides, not the presenters mode. Okay.
Perfectly. Yes.
Okay, great. So hello everyone. My name is Fangqing Song. Thanks for the invitation from Ishan. And I'm a research fellow at the University of Leeds. And today I'll be presenting our cross-country analysis on air travelers' preferences towards greener air travel. It is conducted together with Professor Krishma Chaudhry and Kiara Kalastri. So we are living in an era that requires greener air travel. This is because aviation contributes significantly to the climate change, and air passenger demand is predicted to grow very quickly in the next couple of decades. So although some market measures such as carbon offsets and carbon taxes are in place, the technological advancements such as sustainable aviation fuels and the zero carbon aviation technologies are believed to be the key in mitigating air travel's environmental impacts. However, those SAF and zero carbon aircraft technology, they are still at their early stage. SAF's adoption rate remains very low, and electric aircraft and hydrogen aircraft, they are still not yet commercially available. The existing studies are in this field, in this context, are mainly accumulated in the engineering and or calculating the environmental impact of air travel, while the travel behavior studies in this new context are rather limited. And specifically, there are no studies that jointly consider conventional aircraft, self-powered aircraft, and the different types of future zero carbon aircraft at the same time and explore air travelers' preferences towards different kinds of aircraft. And understanding this acceptance and preference between different aircraft types is, however, very essential because that's important for the transition towards greener aviation. And in the present studies, we mainly focus on 4 research objectives. The first one is to quantify the impact of level of service attributes and the social demographics on air traveler decision making. Although there are many studies that explore this topic, the impact of some factors remain inconclusive. For example, females and age. And the second research objective is to explore the impact of some unobserved psychological factors. There are a bunch of studies that found for example, the positive impact of personal norm or social norm on pro-environmental behaviors, etc. And the next objective of this present study is to examine, well, as the title of the presentation indicates, we hope to explore the preference heterogeneity between different countries. And this is because achieving net zero aviation requires coherent and coordinated global effort between countries, and it is essential to understand the similarities and differences between countries. And the last one is to understand the willingness to pay for. Sorry, a second, my kitty is on the desk. Right. So the last one is we also hope to shed some light to the willingness to pay for travel time and also carbon emission reductions, which is also known as value of green. So most of the current value of green studies are conducted in the carbon offset context, while limited empirical studies have been focused on SAF or zero carbon aircraft. So I'm now going to give a brief explanation of the survey and the sample. So we designed a comprehensive survey which asked respondents about their experiences with different travel modes, including flying and also different ground modes. And then the survey also asked about people's knowledge and views towards, for example, SAF and different kind of zero carbon aircraft. It is followed by a city choice experiment, and then respondents were required to respond to a list of 22 attitudinal statements. The survey end with some social demographic questions. So regarding the city choice experiment, we have 5 different versions that you can see here, and they differed by the trip distance. And each different design offered different choice set. As you can see that, for example, electric aircraft is only available in D1 and D2, which are very short haul trips with flight duration under 2 hours. So in our survey, respondents were allocated only to the most relevant design, mainly based on the flight duration of their last flights. And here is an example of our city choice experiment. And this is a long-haul trip scenario where you can see that respondents were also to make a choice between hydrogen, SAF, and conventional fossil fuel aircraft. And these alternatives are described by a few attributes, including the in-vehicle travel time, the connection time, CO2 emissions, baggage allowance, travel costs, uptake rate, and access time. So regarding CO2 emissions, we present the carbon emissions in numbers, in kilograms, together with a polluted cloud, of which size is proportional to the emissions. And also regarding uptake rate, it is attribute only applied to aircraft options, and it describes the number of people out of 10 who are expected to use a specific aircraft type regularly. So we implemented the questionnaire on Qualtrics and rolled out the survey last year across different continents, and making sure that the sample is representative of age, gender, and income in each country. We cleaned the data following some cleaner rules. And for the present studies, we focused on leisure travelers in economy class. So this table shows the sample distribution in each country. I'm not going to get down to the details, but as you can see that China sample size is relatively small because we removed quite a lot of business travelers from the Chinese subsample. And we can see that senior people have a larger share in developed countries, and we see females dominate in UK and US, and low educated respondents have a very high share in our Swedish and Italian subsamples. While contrary to that, in Chile, China, and Japan, we have a higher proportion of people with at least bachelor degree. And this graph shows the distribution of the chosen options in each seat choice experiment, and we can see that electric aircraft were chosen most often in D1, D2, which are short haul scenarios, and SAF, which is denoted by the light green, its share increases with the trip distances. Now let's look at the data analysis. So basically, we performed the exploratory factor analysis based on the attitudinal statements, and we identified 6 latent factors, and which are later used in our models. We need to note that factor 5 is, however, not included in modeling later on because it's related to frequent flying or distance flying, which is not really relevant to using greener mode or new mode, which is the topic of this present study. So looking at each factor one by one. So the first factor we identified as personal norm, and it is used to describe the perceived obligation to adopt specific pro-environmental behavior. For example, in our case, we mentioned something about, like, for example, responsibility to take the environmental impact into account, or the responsibility to reduce emissions from air travel, my responsibility to support policies, etc. And social norms, on the other hand, describes the extrinsic social pressure on performing pro-environmental behaviors. For example, in our case, we focus more on the like the social pressure related to flying less and using non-aviation alternatives. And then the next factor is related to belief, and in our case, we specifically focus on the awareness of flying's environmental impacts, which are reflected by these 2 statements. And the next category is perception, and we focus on the perceived image of using greener travel modes, and they are reflected by these 3 statements. So basically, it's capturing the agreement to basically this latent fact is capturing how to what extent people agree that using cleaner modes can alleviate people's social image. And we also consider this perceived satisfaction of rail journeys, which are measured by these 3 statements. Finally, we have this personality trait, and in our case, we specifically focus on the openness to change and the novelty, as some literature has found a positive role of this in technology acceptance. And we try to visualize the relationship between the average factor scores of each factor and some social demographics, and we can see that younger individuals, they tend to score higher, which are associated with curse here. So they score higher on all pro-environmental factors from F1 to F4. so are better educated individuals on the top. And we also found that the females, compared to males, they show stronger pro-environmental tendencies. As you can see that compared to males, they have stronger personal norm and more stronger awareness of flying's environmental impact. While at the same time, they perceive less social norms and perceive less agreement with the benefits to social image from using greener modes. So against the country, we can see that, for example, China score higher on F2 and F3, which is about social influence. And regarding the awareness of flying's environmental impacts, we see that Japanese and China's score relatively lower compared to the other countries. So let's now move on to the discrete choice models. So in order to incorporate the extracted latent factors and understand their impact on choices, we developed this ICLV model, where you can see that the utilities are explained by the attributes, the level of service attributes, and also some perception composites and the social demographics characteristics. The latent variables are used to explain the alternative specific constants, and each latent variable are reflected by some associated attitudinal statements, indicators. And specifically, we tested different structures and found the current one works the best, which is instead of using a social norm and awareness of flying's environmental impact, to instead of use them to directly influence the utility, we found they work better and by using them to explain the personal norm, so that these two latent factors actually play an indirect impact on the utility, on alternatives utility. So I will not go to the details of the utility functions, but in short, we most of the we applied the linear specification except for travel cost, where we actually applied a box cost transformation for travel cost, and for all the other parameters, we use a linear specification. And as I just mentioned, the ASC delta are like, for example, the latent variables are used to explain this are used to explain this ASC delta, together with some social demographics and also the perception composites. And so okay, so the estimation results. Well, there are a lot of numbers here. So let's first look at the ASC. So our ICLV models basically reveal that all else being equal, the electric aircraft is most preferred and followed by rail and hydrogen, and then SAF compared to the conventional aircraft. The country differences are reflected by the shift terms of ASC, where we found that compared to the base country, which is UK, Chinese and Japanese may dislike driving more than the other countries, where Swedes, Chileans, and Italians and Chinese, they or may have a stronger preference towards rail, electric aircraft, hydrogen aircraft, and SAF aircraft, respectively. The negative design shifts for medium and long haul trips suggest this utility of hydrogen aircraft and SAF aircraft associated with longer trips. Okay, and now this table summarized the level of service attributes in the choice model. So we can see that all attributes except for baggage, which is highlighted in red are significant and carry the expected signs. So regarding time sensitivities, we found that the time sensitivity on road travel is almost zero. People are not so sensitive to time if they choose a car or coach. And regarding the cost parameters, the box cost transformation suggests that a strong linearity in travel cost. And regarding transfer, we have this continuous variable of connection. And on top of that, we also have these dummy variables to capture the impact of direct services. And we can find that direct flights are more favored on medium flights. We also found a significant parameter for the carbon dioxide, and also uptake rate, and also access time. This table shows that the latent variables significantly influence the responses to their associated statements. And the definition of each latent factor is listed in this column. And the red cells are negative and basically indicating that the interpretation of the underlying latent factor need to be flipped. So the second latent factor actually can be interpreted as disagreement with the benefit of using greener modes on improving social image, and the fourth factor could be interpreted as disbelief in flying's consequences. And this one, instead of saying technology resistance, is actually measuring technology openness. And moving back to the choice model component, and now we are seeing how the latent variable influence the utility functions of each alternative. And then we can see that a stronger social norm would increase the choice probability of all greener modes, including rail, electric, aircraft, hydrogen, and SAF aircraft. And then we can also see that for someone who this section also is indicating that the stronger an individual agrees with the benefit of using greener modes on improving their social image, the more likely they will choose greener aircraft. For example, electric, hydrogen, and SAF, and less likely to travel by private car. And also we found that the more open an individual is towards new technology, the more likely they will choose new aircraft types like electric, hydrogen, and SAF. This one is saying that stronger satisfaction with rail journey in the past also increases the chance to select rail. And regarding the anticipated perception of each different greener aircraft, we also see a positive relationship. And our model also confirms the positive impact of social norms and and also the belief in flying's environmental impacts on shaping and strengthening personal norm. And the latent variables are explained by a series of social demographics in the structural equations, and most of the covariates shown here carry signs as expected. For example, females are better educated individuals tend to have a higher personal norm, and younger people and better educated individuals, they value more on the benefits of using greener modes on improving their social image. And the females, younger individuals, and students tend to be more aware of the belief in environmental impacts of flying. However, what seems a little bit counterintuitive is that the younger people here were found to exhibit a weaker personal norm. We cannot yet conclude on the reason behind this and need to further explore if the age is correlated with other variables that reduces personal norm. And and then we also consider country differences in determining the latent variables in structural equations. For example, we found that Chinese, Italian, and perhaps also Japanese, they have higher agreement on the benefit of using greener modes on improving one's social image. And regarding social norm, we see that Chinese people, they perceive stronger social norm, and this is possibly can be related to their well-connected HSR network that enables the substitution of air travel by rail on short-term distance. And as to factor 4, which is the belief in flying's environmental impacts, we can see that the model indicates a stronger disbelief in air travel's environmental impacts among Americans, Chinese, and the Japanese. The reason behind still needs to be further explored, but we think potentially it could be related to that some people might think that individuals' air travels are indispensable, and they tend to underrate flying's emissions in these countries. And also, what seems a little bit counterintuitive is a low level of personal norm of Swiss. This we still need to explore the reason behind. Potential reason could be that there is a gap between the progressive government's policy and public's actual attitudes on this. And also the wording of responsibility might sound preachy to some people. We report the willingness to pay estimates for the value of time and the value of agreeing by different trip distances, and so we can see that we found a higher value of time and also VOG on longer trips, and this may be due to the reduced sensitivity of travel costs on longer trips. And regarding the VOG, we can see that when we use the CO2 emissions in kilograms in our model, the results turned out to be at the higher end compared to the existing studies. But one possible reason could be that we are including longer distance trips in our sample. And also, we estimated another model that instead of using CO2 emissions in kilograms, but instead use the relative CO2 and keeping everything else the same. And the results is saying that people are willing to pay this amount of money to reduce 100% of carbon emissions, which are much lower compared to these results using kilograms in the model. So this opens the question of whether the unit of CO2 emissions makes a difference to respondents' perceptions, and this remains unclear. We still need to further investigate on this, and perhaps this requires further behavioral experimental tests. So some conclusion and insights. So our model confirmed the finding in literature that the personal norms access a positive and direct predictor of choice of greener mode, and the social norms influence pro-environment behavior indirectly through personal norm. So this might indicate that it would be beneficial to improve the availability of alternative modes to make it easier for people to fly less. And the second is that the personal norm is also positively shaped by environmental awareness and knowledge. So this is telling us that it is crucial to educate the public to increase their awareness and knowledge of flying's environmental impact and facilitate the internalization of those knowledge. And thirdly is that the perceived satisfaction with rail journey is found to increase the chance of choosing rail. So we think that it is essential to improve the service level of the rail system if we are hoping to substitute short-haul flights with rail. And also, the results showing that Eastern Asian countries, for example, China and Japan, tend to be more affected by social influences compared to Western countries in the adoption of pro-environmental behavior. We, however, do not find a significant impact of technology resistance on choices, but the anticipated perception of the new greener aircraft's performance plays a positive role in choices in people's choices of greener aircraft. So that's my presentation, and comments and the questions are welcome. Thank you.
Thanks, Fangxing. And I can see you already have 3 questions. But just given the time constraint, I'll just request if it's possible, you can directly reply to the question on the chat box, and we can move to the next speaker then.
From where? Okay.
Yeah, so I can see there are 3 questions, one from Shubroto, next one from Nasir, and one from Patricia. So feel free to reply to them directly on the chat box. And we'll move to the next speaker. That's Dr. Patricia Laveri from University of Melbourne, who focuses on development of more sustainable and equitable societies, leveraging smart technologies. So today she's going to present findings on how paying to offset carbon emissions impacts intention to reduce air travels and across Brazil, US, UK, and China, which I think is a very natural continuation of what Fangxing just presented. So, Dr. Leveli, this stage is all yours. Feel free to share your screen and start the presentation.
Thank you. Can you see my screen already?
Yes, perfectly. Yeah.
And is that the right presentation view? Yeah.
Yes.
Okay. Yeah, thank you so much. Yeah, I think it's a great continuation, and it's interesting to see that hopefully when I reach my conclusions that there are some that are very aligned. So yeah, hi everyone. I'm Patricia Lavieri, and I'm a senior lecturer in transport engineering at the University of Melbourne. I must say that IATBR conferences are my favorite, so I'm actually really happy to participate in this mini session at BTR, and I actually feel very honored to have been invited to speak among this great lineup of speakers. Since it's my first time participating in BTR, I also wanted to thank their organizers, because I find that this is a very inclusive initiative that has been playing a very important role to my PhD students, given that we are in Australia and it's far from everywhere, and it really gives them an opportunity to share their work with the world and receive feedback even when we have limited resources for travel. So today I'll be presenting some work that is still in progress, but it's actually fruit of IATBR 2022 in Chile, where I met Jacek Polak from Imperial College London, and then I started collaborating with him and Aruna Sivakumar, also from Imperial. And in this work, I'm gonna explore the relationships between paying to offset carbon emissions and associated with travel, and the intention to actually reduce air travel. And I will compare travelers from 4 different cities. So as I just mentioned, I'd like to acknowledge and thank Jacek and Aruna for sharing this data set that I was very interested in, because it contained data from Brazil, which is my home country. And I also would like to thank my recent graduate, as Ana Luisa, who helped me switch my modeling methodology over the weekend, as I just completely changed my model and found some much more interesting insights. Lastly, I'd like to acknowledge the traditional custodians of the land where I live. They were the wrong people, and where I work, they weren't the Jerry people, and pay my respects to elders past and present. This picture is the beautiful cultural heritage place called Point Impossible, where I have the privilege of surfing on my free time. So back into business. So what is carbon offsetting? If you are not familiar, carbon offsetting is the idea of investing in projects that reduce or remove greenhouse gases from the atmosphere to counterbalance emissions produced elsewhere. In the sense, if an activity cannot reduce its emissions, those conducting this activity can compensate for their carbon footprint by conducting carbon negative activities. For example, they can plant trees. And considering the significant carbon footprint of air travel, and because air travel still strongly relies in fossil fuels, carbon offsetting became an attractive option and started to be discussed and actually implemented around 2016. And then around 2019, it gained a lot of popularity in developed economies. In some cases, companies could choose to pay to offset the carbon themselves, but the usual approach has been to offer consumers the option to pay for the offset. And that for consumers to choose to pay, that happens, for example, this is an example that I extracted from China Airlines website. After you have purchased your flight, you can go to their calculator and identify what is your carbon emissions, and then you can choose to pay separately from your flight the equivalent to offset carbon. Another option is one from Brazil. In this case, this company offers during the booking, you can choose between two options, one more affordable and another more expensive, and then you can include these options in your flight and then pay for the carbon offset in this way. Another third way that this might appear to consumers is this example from the United States, from JetBlue, where you can actually look in their website separate from the booking system on how to pay for offsetting, and that's going to take you actually to a third-party company website, and there you based on an estimate of amount. As I mentioned earlier, some took responsibility for the offsetting as part of strategies. However, many of these initiatives were actually labeled as greenwashing and criticized for deviating attention from actions that would actually reduce emissions, such as transitioning to sustainable aviation fuels. The tricky part of carbon offsetting is that it's very difficult to measure if the money was indeed invested in something that generated actual carbon offsetting. And many of the strategies, many of the programs actually involve planting trees in developing economies or other initiatives that change the behavior, not in the country of origin, but in a different country, usually developing economies. So it's very difficult to measure. the effectiveness of this money invested in carbon offsetting. And indeed, some companies were scrutinized for offering offsetting programs that were realistically cheap, and were also criticized by offering that while expanding their domestic flight coverage. For example, in the UK, in situations where other modes could be used because the flights between cities that are connected through other modes such as rail. In the sense of a mode choice, from the consumer perspective, offsetting may also be serving as a cushion, especially for domestic travel in places like Europe, where there is an extensive rail network, and it also includes fast rail. But in other countries, not as much. For example, in Brazil, even major cities, they are only connected by road. There is not rail connecting major cities within the country. And so in these cases, in the cases that there is an alternative mode, switching modes or a modal shift would be probably more impactful to the environment than paying for trees to be planted somewhere else in the world. So with that in mind, I'm investigating the question, for whom is carbon offsetting replacing or supplementing efforts to reduce air travel? I use reviewed preference data collected from residents from 4 major global cities. London, which has a population of around 9 million, New York, which has a population of around 8 million, São Paulo in Brazil, which has a population of around 13 million, and Shanghai in China with around 25 million people. And those numbers don't include metropolitan areas. The data, as I said, was collected by my colleagues from Imperial College, and that was during the project Acclaim, and that was in 2020. However, the journeys of reference of this reviewed preference survey were in 2019, which is prior to COVID. What is very interesting about this data set is that it includes both Eastern and Western culture countries and emerging and developed economies. Each city had a target sample of around 500 respondents, and there was a quota for business travelers of around 20%. So to understand the relationship between paying for carbon offsetting and air travel behavior, I'm analyzing a combination of 6 different response variables. The first one being payment of carbon offset on the last flight, and the respondent had the option to say, no, I did not pay because I did not want to. No, I'm not familiar with carbon offset schemes. I wanted to pay, but there was an option, and yes, I paid for carbon offsetting. The other question was the intention to change air travel frequency due to environmental concerns, and the answers could be no environmental concerns with respect to air travel. I intend to increase the amount of my air travel despite my environmental concerns. My air travel is likely to stay unchanged, and my air travel is likely to be reduced as a result of environmental concerns. We also measured their general climate change concern, which could be from very unconcerned to very concerned. We measured their frequency of air travel for work purposes, going from never to very often, which is more than once a month. and the same for frequency of air travel for other purposes, such as tourism or other attending events, for example. And lastly, and importantly, regarding the mode alternatives, we asked the consideration of alternative travel modes. So whether they could choose that, they could say that they were aware of other options, but always preferred to travel by air. They could say that air travel was the only practical option in that situation. And they could say that they did consider other travel modes, but ended up choosing air travel. And here I want to investigate these variables together because I want to know if payment is compensating for the intentions to increase air travel, or if those paying are also trying to reduce their flying frequency. I also want to see if people who know that there are other options, other modes available, but still choose to fly are perhaps playing out of guilt. So for my analysis, because I have multiple categorical variables of interest and I want to identify and characterize clusters of similar cases and investigate the relationship between these variables, I use the latent class cluster analysis. I use the R package Polka, have the link down here if somebody is interested and wants to use it as well. As I mentioned before in my acknowledgements, I had a last minute change in my model conceptualization because first I had conceptualized this as a bivariate multinomial probit model that I was going to jointly model payment and intention to reduce flight frequency, but I was not able to disentangle some levels of heterogeneity, and then I decided to change to the LCCA. Happy to talk to any students who may be going through similar situations. Yeah, and just a little bit about the LCCA model. So the LCCA model embeds a clustering mechanism to cluster the observations based on a discrete latent variable. And it also has a class membership model in the logit form that accommodates for the explanatory covariance. So the parameters that are estimated by the model are the proportion of observations in each latent class and the probabilities of observing each response to each manifest variable conditional on the class. So let's jump to the results. I'm trying to keep track of time to leave some time for Ishan, but I kind of lost track of time. So please let me know if I'm
it's
going
like
too
we
long.
have 1 or 2
Yeah.
minutes left, but it's fine. It's fine. I can accommodate you.
All right. Okay. All right. So based on the data feed and on the empirical meanings that I was deriving, I identified 4 main classes. Class 1 that I named the unconcerned sporadic travelers. And they are not very concerned, but we are also not very concerned about them because even though we see that they are rejecting to pay for carbon offsetting, and they don't seem to be environmentally concerned about their air travel, they are also very infrequent air travelers. So, and they seem to find that there is no other practical option rather than traveling when they do travel, but they are not traveling that frequently. Class 2 is the group that I named the reduction enthusiasts, because they show the highest probability of reducing future air travel. And these are medium frequency travelers, and they present the second highest probability of actually paying to offset. So this group is actually trying to do something about it. In many instances, it appears that there are alternative modes that they could be using, and that's probably why they may seem to be willing to change. Class 3, I named the emerging Brazilians. As you see in the next slide, more than 90% of this class are Brazilians. So it really separated this nationality here in the model. And they are low to medium frequency flyers, and they are were mostly unfamiliar with carbon offsetting, which made sense since in 2019 the local airlines in Brazil were not offering offset options. I call them emerging because they are the group with the second highest probability of intending to increase the amount of travel. And as I mentioned in the beginning of the presentation, Brazil doesn't really provide any rail option for intercity travel. Lastly, class 4 is the class that we are worried about. Those I named the corporate offsetters. They fly very, very frequently, mostly for work, but they also fly for other purposes frequently. And they foresee that they are going to increase even more their air travel, and they tend to pay to offset. In terms of demographics, I'm not gonna go here in detail. I wanna keep my presentation a little bit shorter, but as I mentioned before, it's interesting to see how class 3 is mostly formed by Brazilians, and class 2, who are the reduction enthusiasts, we see a significant share of Chinese respondents. So we might have something to learn there from there. They also tend to be have higher education, so above bachelor, similar to the corporate offsetters. Corporate offsetters tend to be male, relatively young adults, between 25 and 44. And they are paying to offset, but they are also paying for priority boarding, and they tend to be loyalty members, and again, because they are very, very frequent flyers. So jumping to some discussions and implications. One thing that I forgot to say in this previous slide is it's interesting to notice that while class 1, 2, and 3, we see some predominance of certain nationalities. For class 4 is the one that it's more evenly spread. So perhaps the corporate offsetting behavior is something that is cross-national. So it is something that we should be worried about at a global scale. And one question that I leave for us to think about and perhaps act on is, are they paying enough for the amount that they are flying? Is this really, or are they creating a huge carbon footprint that is impacting everyone else, and they are not being held responsible enough for it? And should then be corporate level measures to compensate for that. What I mean by that is, should we be allowing companies to have their employees flying that frequently if the flights are not green? And then a question was, has this changed after COVID? As I disclosed earlier, this data sets prior to COVID, and after COVID, with the huge increase in ICT use, there was a sense that business travel was going to decrease. However, it seems that since late last year, numbers are already exceeding 2019, so business travel does not seem to be reducing. Regarding the emerging Brazilians, I believe there is a worrisome lack of alternatives to domestic flights. So it is very important that sustainable aviation fuels become status quo in the country, because nothing is being invested in alternative modes. But as we see, Brazilians are not paying for extras in flights, so they may also not be paying for offsetting in this new market. Lastly, to finish my presentation, I think we have a lot to learn from the reduction enthusiasts. What can we learn from China? But the final question to be investigated in a future study is whether this intention to reduce air travel, is this intention translating into real behavior change? We don't know, and we need to confirm that. Thank you.
Thank you, Patricia. It's a quite an intriguing presentation on how you find different clusters. So, considering the time constraints, I'm not taking direct questions, but always feel free to have your questions in the chat box. And I guess Petra should be more than happy answering them directly on the chat box.
Thank you.
And so I'll rush through the presentation because I understand the people will also like to join the other BTR session. So I'll not take much of their time. So, and if you're interested to know more about this work, feel free to scan this code. It's already available as a preprint. We have submitted in the Journal of Air Transport Management. So you can read the preprint and come back to me at later stages with your queries, or if you find anything interesting, if you have any suggestions particularly, I'm always open to all of those things. So now, so yeah, as I said, I just rush a bit considering the time constraints. So just to understand the motivation of this study, where we are trying to understand what happens when these futuristic modes, for example, these flying cars, which is formerly known as urban air mobility, comes into play. So the existing studies, or largely the existing studies which are focusing on adoption and usage of these modes, are mainly focusing on the change of value of time, or they're also working on how the attitudes and perception from the user or potential users and non-users perspective. And mainly they're taking the stated preference approach, which has a certain limitation in terms of being cross-sectional in nature, or in terms of sample size or survey bias. And one of the interesting thing is that whatever the stated preference approach is capturing, the perception or people's reaction to these emerging modes, which are not a reality but will soon be a reality, it will change over time, and it is different across various countries because context, culture, and all those things matters, as we have seen in our previous presentation, especially in context of air travel, where Fangxing and Patricia talked about them. So can we use large-scale passive data set, for example, social media data set, which has distinct advantages in terms of especially these three things. That's it's large scale, and we can collect a data set for a long period of time. It's of course less survey bias because we're not asking direct questions to the respondents, so in that we are not making them biased. And also it is easier and cheaper to collect data in that scale, but it as always comes with its own challenges, because we sometimes do not get the precise location information, and there could be potential sentiment bias arising from the short text, for example, in Twitter. And of course, we all know about the non-representativeness bias of the sample. So in this particular study, we kind of solved the first two things. We collected geotag data, which solved the locational issue of the social media data. And secondly, potential sentiment bias was taken care by our methodology. So as I was saying, there are two key research questions aiming at two potentially different policy implications. The first one is, how can we assess the spatiotemporal heterogeneity in sentiment polarities, like positive, negative, how it changed over time, and how is it changed or how is it different across countries? And secondly, can we identify what are the underlying themes of this discussion? Because it is not only enough to understand the sentiment polarities, it is also important to understand what are the factors which are kind of determining these kind of polarities. So in terms of methodology, we started off with the sentiment analysis, which gave us the idea about the sentiment polarity. And here we used firstly some machine learning, and then we also switched to some transformer language models, state of the art like BERT. And to understand the difference in terms of spatiotemporal heterogeneity, we used first the time series analysis and for the temporal study, and then for the spatial differences, we used K-means clustering. And from then, as I talked about, how can we detect the underlying themes? We used dynamic topic modeling. Why dynamic? Because it is not only trying to understand the underlying theme, it is also detecting how each of these themes changed over time for different clusters that we identified through K-means clustering. So within dynamic modeling, we started with different context-based categorization and then ended it with the content analysis with LLM. And it's also important that here we actually used or leveraged the power of GPT-4 or GPT 3.5 turbo, I guess, which gives us an edge over the other type of these language models. So this is the full methodology. I'll not go into detail considering time constraints. So a brief and quick idea about the data set. We had collected 12 years tweet data set spanning from 2020 to 2021 and across 6 countries. So we collected total around 16,000 geotag tweets from each of the countries where we get at least 1 million Twitter users. And on the right chart, you can get an idea about the spatiotemporal pattern in terms of count of tweets in these countries over this whole 10-12 years period. Regarding sentiment analysis, as I explained, we started off with some machine learning model, and among which we found that SVM perform-based support vector machine. So I'll not go much into these technicalities for now. Just to get an idea, we found the SVM performing best out of the machine learning models, whereas BERT model we found as the best of the lot. It even outperformed the SVM model in terms of classification, or in terms of classifying the tweets in different polarities. The reason most likely could be its pre-training approach, its bidirectional nature, and obviously its encoder specific architecture. So now get some idea about how the temporal trends change and whether our analysis is actually matching with what happened on ground. It is actually matching. So we could find that the interest spiked around the 2017-18 period. And also it's important to understand, so whatever picture I'm currently showing, it's some kind of aggregated picture of all 6 countries together. And that's why we kind of also devised another index called sentiment index, which is simply as a difference between number of positive tweets and number of negative tweets. So basically, sentiment index is giving you an idea how positive the sentiments are in a particular point of time over this 10-12 years time period. But again, it's an aggregated picture. But the aggregated picture actually kind of portrays the reality pretty much well. It captures that in 2017-18, the interest spiked higher, and which can actually be related to announcement of various ambitious plans and also various public demonstration or prototype development by leading industries, for example, volocopter, joby aviation, like that. Also, on the other hand, we found that during 2015-16, just 1 or 2 years prior to that, there was a little bit high rise in the negativity, which actually could relate with few drone-related incidents or accidents, and there were some public concerns regarding the possible externalities or negative externalities of urban air mobility in terms of, say, noise pollution or like visual pollution, safety, security, like that. But still, this aggregate picture is not giving us that whether can we find the country specific differences and can we understand why we are seeing there is a gradual decline over time in terms of sentiment index or positivity with respect to urban air mobility sentiments. So going into the differences across countries, so when we used k-means clustering over these tweets, we could find based on the sentiment polarity, which includes positive, negative, as well as neutral tweets, we could find 4 specific country clusters. The first country cluster includes USA, Australia, second one, Canada and United Kingdom, third one, Germany, and fourth one, India. And you can clearly see from the plot on the left that these clusters significantly differ in terms of their polarity. So for example, the first cluster is high on both positive and negative sentiments towards urban air mobility. That means people there are quite more opinionated, be it positive or negative, they're quite more opinionated. Whereas you move towards the right, for example, in Germany and India, you'll find that it's quite high in terms of neutrality in those clusters. So once we got the understanding, aggregate understanding of the temporal change and also the spatial clusters, so now it's time to understand what are the underlying themes, and with that we're trying to understand what are the factors that kind of determining this kind of sentiment polarity. So we used a dynamic topic model, as I mentioned before, and we found, so this is an aggregate picture of what cloud you are currently seeing on screen. I'll go much into detail about each of these countries, but on aggregate, we could find people are actually talking about the industry and innovation pertinent to urban air mobility. Then they're talking about unmanned aerial vehicles, unmanned part of the aerial mobility, and they're also talking about testing, implementation regarding that. So what we did, or rather what the dynamic topic model gave us, it gave us a ranking of different topics or underlying themes for each of those clusters, and it also showed us how it changed over time. So I'll get to that part, how it changed over time, in the subsequent slides. So in this slide, you'll get an idea that the ranking of different factors for each of these clusters. And for example, there's one key takeaway is that you can find some of the topics, for example, industry, innovation, and testing, which is also apparent from the word cloud, that it is prevalent in almost all the clusters, and in all the clusters, it comes in the top 1 or 2 topic. In fact, it is the top topic in 3 out of 4 clusters. Another interesting takeaway is that, for example, excitement is common in all cluster A and B and C, but the ranking is different. For example, in cluster A, sorry, yeah. So in cluster A, I could find that the excitement is the topmost factor, whereas for cluster and B and C, you could find the excitement, the ranking of excitement, it's still there, but its ranking of excitement is going down. So it is not as important factor regarding urban air mobility as it is for the cluster A. So now the last part of it, going to the country-specific trends. So we'll start with cluster A. So what we observed is that public sentiments is very much related to the key development in terms of industry announcement, in terms of, say, prototype development or public demonstration. And that we observe, say, in the 2015-16 period, we could find there's some announcement, some storytelling about the flying cars, and it actually impacted the public sentiments. And also during the 17-18 period, when there was some launch of prototypes, the public sentiment of excitement regarding urban air mobility is also actually spiked up. Secondly, we could also observe due to some policy bottleneck or lack of implementation policies, there is a loss of initial interest as it actually gradually goes down in the last few years. And of course, delayed layout could actually also cause the excitement loss. What we could do, what could be the possible uh, policy takeaway points is that there need to be a very clear timeline. Otherwise, the initial interest kind of fizzles out. A timeline for the implementation or rollout of these kind of futuristic modes. You need to bring public on board. You need to have their concerns, their interests, and all the things quite well. So you go for public consultation, and there need to be a clear framework how you integrate urban air mobility into the existing transportation framework. Similar way, when the cluster B, which includes Canada and UK, we could find some interesting features here. For example, first one is we could find as compared to cluster A, excitement is not the topmost factor. Rather, we could find higher prominence for industry and innovation, which actually kinds of mirrors or reflects the contextual and cultural difference, which also in a way is a proxy for the attitude difference for people. Secondly, public reaction is more intense with negative incidents. So if you feel that there's a red dotted line, and I have kind of marked it with a dotted box in gray color. So there was an accident, but in Maverick accident, Maverick is the company which faced that accident. So when that accident happened, kind of public reaction spiked up, but over time, it also kind of went down pretty quickly. But you need to understand that whenever there is this kind of negative incidents, there will be strong public reaction more than the positive ones. And also, the traction for innovation might not be proportional to the excitement if it is not happening here exactly. For example, you could find that 2017-18 there was some global announcement, but most of these companies are based in USA and some of them are based in, say, Germany, not the homegrown companies in the UK. So there was public reaction to these global events or global announcements or prototype development demonstration, but that doesn't mean that this will create the excitement back at home always. What can be done? The innovation should be followed with demonstration to create excitement and interest in public, which could facilitate adoption of it. Second one is the confidence building is really necessary, especially in this part of the world where people are sometimes skeptical about the possible negative externalities, for example, pollution, noise pollution, safety, security, more than the other parts, for example, US and Australia, where people are more uncertain accepting. So based on the context, your policy decisions could be changed or actually need to be changed. And of course, the integration of UM, that remains constant in this cluster too. So third cluster, cluster C, India, we could find that industry innovation also plays an important part here, but the reason for this could be a little different from what we found in UK and Canada cluster, because the context here is different, and also it matters how there is a policy focus shifting to the use of urban air mobility, not mainly for the passenger transport, but rather in the freight category. And the point is that you could find a very low lying excitement, which could be related to the quite distant horizon in terms of the socio-cultural context or even the infrastructural context of countries like India and few other countries in global south, which calls for certain policy implications. So the innovation plus demonstration part remains constant, but in India and similar countries in global south, we need to concentrate more also on the how we can frame mature policies. And while we integrate the UM, we also need to be more careful about the inclusivity part, so that when we bring this UM or integrate, it should not create some kind of divide in our society. So from the equity aspect, that's pretty important. Coming to the last cluster, that's Germany, you could find there's higher prominence for industry and innovation, which is expected considering there are a few of these companies which are based in Germany, which were leading in terms of manufacturing these flying cars or this, for example, volocopter like that. And then we also need to understand for them how tangible benefits, where we found that in the context of Germany, people, as compared to other countries, are more interested to understand what kind of benefits this urban air mobility mode will bring into our life. For example, is it going to save time if it is used in freight, whether the logistics supply chain could be more, even it could be better or not. So if that's the aspect, for example, in these countries, that should be the policy focus. So in general, the innovation and demonstration and integration of with a specific focus on the utility aspect of it. So to sum up, the dynamic topic modeling. So first we started, as you have seen, we started off with the time series and spatial clustering, which gave us the aggregated picture, but with help of dynamic topic modeling, we got a very precise picture of what each of these cluster needs in terms of their policy rollout for urban air mobility and its successful integration in the existing system. So with that, I'll conclude my presentation. Thanks to everyone for your time and being here. So yeah, that's all from my side. Yeah.